Hello and welcome. In this video we will explore how DACs are modeled and operated in ADIsimRF. ADIsimRF is an easy-to-use RF noise and distortion calculator that can perform cascaded analysis of signal chains with up to 50 elements. Because they are so different from a typical RF component, creating models for DACs in ADIsimRF is a little bit challenging. However, the DAC models that we've created in ADIsimRF do work well and return accurate simulation results. Let's start by loading an RF DAC using the device selection wizard. Next, we select the DAC device type and the desired operating frequency, which in this case is going to be 1000 MHz. The wizard offers us two versions of the same device, AD9162. These two versions are simply two different operating modes for the same device, and these modes are described in the comments column. So let's select AD9162 V1. Once the DAC is loaded, it can operate just like any other component. We can perform frequency and Dbfs sweeps. You can see that the DAC has a gain pull down. The so-called gains here are actually Dbfs levels. So to do a Dbfs sweep, you would go to the gain sweep tab. The AD9162 is a single channel RF DAC. ADIsimRF also has models for dual DACs that are usually used to drive IQ modulators. Let's again use the wizard to load one of these. These dual DACs operate in exactly the same way. One thing to watch for with these particular models is that you should set the input power in the input frame to 0.97 dBm to ensure that the calculated DAC output power comes out correct. To adjust the output level of the DAC, you should use the gain pull down and generally leave the input power setting to plus 0.97. Now, when we look at the available Dbfs levels, the numbers look uneven. This is due to the fact that our output frequency is 100 MHz, so we are on the DAC's sin x over x roll-off curve. If we place the output signal at baseband, and we do that by setting the output frequency to 0, and again look at the pull downs, we see that the Dbfs levels are the even numbers that we would expect. Thank you for taking the time to watch this video. For more information and to download ADIsimRF, please go to analog.com/ADIsimRF.